Welcome to the screencast for Distance Formula, Part 1 on the grid. In this screencast, you will learn how to find the distance between 2 points on a grid or on the coordinate plane. Within the scheme of our lessons, in order to understand this distance formula, it would be a good idea if you reviewed Pythagorean theorem. And the reason why we use the distance formula is to be able to work with more advanced shapes. Circles, more advanced lines. So let's take a look at our first problem. We would like to find the distance between points A and B are on a grid. And when we're talking about the distance between those points, we're talking about that particular segment. The shortest distance between 2 points is a straight segment. And what we're going to do is use the Pythagorean theorem. So you might be wondering, if we're going to use the Pythagorean theorem, where is our right triangle? Well, if we look at those vertical and horizontal distances, we have created a right triangle. So our Pythagorean theorem would be leg squared plus leg squared equals hypotenuse squared. And the length that we are looking for is the hypotenuse. One of our legs, if we just count the boxes, would be 6 units. The other leg, if we count the boxes, would be 8 units. So when I use the Pythagorean theorem with 8 and 6, and simplify, continue to simplify, and then we have 100 equals AB squared. What we're going to do is take the square root of both sides. And the square root of 100 is just 10. So 10 equals AB, or the length of the segment between A and B is 10 units, or the distance between points A and B is 10 units. So really, what we've done here is we've discussed a process. We haven't actually used a formula. The process that we have used is to take a look at how we could use the Pythagorean theorem. And we're going to try that again for the distance between points A, this time on the coordinate plane. And A is at -5, 4, B is at 5, -6. So we're going to draw our right triangle by including those vertical and horizontal lines. But how do we actually figure out those particular lengths? Counting the boxes is an option, but sometimes it's not a practical option. Sometimes we might miscount, or the graph is so big it doesn't make sense. So let's see if we can come up with a version of a shortcut. And if I wanted to find that horizontal distance, this green line segment, I'm looking for the change in x, or what we call delta x. And one way to do that is just to subtract my x values. So 5 minus -5 would be 10. So that change in x is 10 units. That horizontal distance length is 10 units. And I'm going to do something very similar for the y segment, or the vertical segment. And I'm going to find that delta y, which just means change in y. And what I'm going to do is subtract my y coordinates. And we also get that y is equal to 10. So now that I have my legs of 10 and 10, I'm going to go ahead and use the Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared. Let's get some more room. And I will substitute my legs both at 10. So we will simplify and simplify. And then we'll take the square root of both sides. And we get that the square root of 200 is AB. Now I want to take a look at this answer. On some calculators, you might get an answer like 14 point and then a large decimal. This is not the answer that you are going to want to use unless we're in a word problem. For our skills that we're working on, we would like to avoid the decimal answer. Some calculators will give you this answer of 10 square root 2. We're just simplifying the same way that you would simplify a fraction or something similar. So the two answers that we would actually be expecting would either be the square root of 200 or 10 square root 2. So to review, again, we have not talked about a formula, we've talked about a process. To find the distance between points A and B, we're going to find a horizontal distance. We do that by subtracting the x's. We're going to find the vertical distance, and we're going to do that by subtracting the y's. And then we apply the Pythagorean theorem. So, again, our objective was to find the distance between 2 points on a grid or on the coordinate plane. We are just not using a formula. We have used a process.